All right, let's dive into one of the coolest and most practical ideas in software design, the microkernel architecture. You've probably heard it called the plugin architecture, and for good reason. It's an amazing way to build software that's designed from day one to grow and to change over time.
So let's start with the big question, right? How do you build a piece of software knowing that you're going to want to add new features later on without the whole thing becoming a fragile mess? How do you add something new without risking the whole house of cards coming tumbling down? That's the challenge this architecture is built to solve.
And the secret sauce here is actually pretty simple. It's all about a very clear separation. The whole system is built on just two main parts. You've got your super stable foundation, and then you have all the cool new things you build on top of it.
Okay, so let's get the official definition on the table. The microkernel style divides all the application's logic into two buckets, a core system and a bunch of plugin components. Now, technically, it's still a monolithic application, meaning it all runs as one unit. But it's a really smart and flexible way to structure that monolith.
So you can really see how this works. The core system is kept as small and simple as humanly possible. It has only the absolute bare minimum functionality needed to get the system up and running. It's that rock-solid foundation. Then you have the plugins. This is where all the exciting stuff lives, all the special features, the custom logic. Each one is a standalone, independent piece that you can snap on to add new powers to the app. I know, this can sound a bit theoretical. So let's make it super concrete with an example that a lot of you probably use every single day. We're going to see how an IDE, or integrated development environment, is the perfect showcase for this idea. And the poster child for this architecture is the Eclipse IDE. If you've ever written code, there's a good chance you've used it. And under the hood, Eclipse is just a masterclass in how to build a powerful system using plugins. It makes the whole concept just click. So check this out. At its heart, the core of Eclipse is basically just a simple text editor. Seriously, it can open a file, you can type in it, and you can save it. That's the entire core system. But then, bam, you add the Java plugin, and suddenly it's a full-blown Java development environment. Then you add a Git plugin, and now it has world-class version control. Each major piece of functionality is just another plugin extending that simple, stable core. Okay. So for this to work without turning into total chaos, you need some strict rules. Rules for how all these different pieces are allowed to interact. Let's look at how the core and the plugins are actually allowed to talk to each other. The communication model is surprisingly straightforward. Every plugin gets its own direct, private line to the core system. Think of it like a one-on-one phone call. A plugin never talks directly to another plugin. It only talks to the core. In the code, this is usually handled with things you're already familiar with, like shared libraries or namespaces in Java or C#. All right, now we get to the really critical part. Most applications have a central database, right? So who gets to talk to it? This is a huge design decision, and it's where a lot of projects can go wrong. Let me tell you the number one way to mess this architecture up: letting your plugins connect directly to a shared database. It might seem like an easy shortcut at first, but trust me, you are creating an absolute nightmare for your future self. It creates a tangled web of dependencies that's almost impossible to manage. Here's the right way to do it. The core system is the one and only gatekeeper for the database. If a plugin needs data, it asks the core. The core then goes and gets what it needs from the database and hands it back to the plugin. The plugin has no idea how or where that data is stored, and frankly, it shouldn't care. Now, there is one important exception here. It is totally fine for a plugin to have its own little private data store. The key word is private. As long as that data store is only ever touched by that one specific plugin, you're golden. It doesn't create any messy dependencies across the rest of the system. So why are we so strict about all this? Why all these rules about who talks to whom and who can touch the database? Well, it all comes down to one of the most important goals in all of software engineering. And that goal, that magic word, is decoupling. This is the big prize. This is the entire reason we follow these rules. By keeping everything separate and communicating through the core, we decouple our components from each other. So what does that actually mean in the real world? It means if you decide one day to switch your central database, say move from one vendor to another, you only have to change the code in one place, the core system. All of your dozens, maybe even hundreds of plugins, you don't have to touch a single one. That is a massive, massive win. So let's just quickly recap the big payoffs here. You get incredible extensibility. Adding new features is just adding a new plugin. You get better maintainability because you can wall off complex code in its own little world. You get awesome testability, each piece can be tested on its own, and you get stability. A bug in one plugin is way less likely to bring the whole system down. It's a fantastic pattern.
So there you have it, the simple, powerful idea of a minimal core with optional extensions. And this pattern isn't just for software. So I'll leave you with this question. From your phone to your web browser, maybe even your car, where else in your life do you see this elegant core plus plugin design at work? It's everywhere once you start looking for it. Thanks for tuning in.